Please join me in welcoming the Chief Architect of Hewlett Packard Enterprise Lab, Kirk Bresniker.
We live in an impatient world. As you heard Meg say, time to value is everything. But how do you get to that value? By speeding, time to learning, time to result, time to publish, time to trade, time to product, time to advise, time to insight, time to experience, and time to action. The definition of real time is changing. The old world analyzes the past, and it gives us hindsight. Real time means analyzing the new while it is still new. Real time means insight and foresight. Walmart, their transactional database is about 40 petabytes. And with that data, they changed not just the face, but the entire practice of in-store retail. By May of 2016, Facebook was processing 4 petabytes of data every day. That's the size of the Walmart database every 10 days. And with that data, they changed the way the world communicates. But we're about to take another leap in magnitude, the amount of data available to give us insight. By 2020, the driver assistance systems alone of the 10 million autonomous cars will generate 40,000 petabytes of data every day. And that's just the self-driving cars. We'll be generating that level of data from IoT sensors all over our cyber-physical world. And the question is, can you capitalize on this data explosion? 99% of the data that's created at the edge is discarded today. When we decide what to keep and what to lose, we introduce bias, and bias precludes new insights. Raw data is priceless. Everywhere that someone works out how to use just a little more of that data to gain real-time insights, entire industries will be remade or unmade. Will it be you, or will it be your competition? There's a challenge, a problem in achieving this. Every 2 years, we're creating as much new data as we did in all of recorded history. And we've kept up till now, but our ambitions are growing faster than our computers can improve. We needed something different, and we have done something different. 3 years ago, on this stage, we announced the Machine, our research project to reinvent computing. We've built the biggest single memory system with 160 terabytes of fast memory. We came with promises 3 years ago, and now I have prototype and proof. It works. We call this architecture memory-driven computing. What can you achieve if you throw away 60 years of convention and compromise? By surgically modifying a few lines of legacy code, we sped up Apache Spark 15 times. By replacing computation with memory reference and lookup, we sped up similarity search 40 times. By writing new large-scale graph inference algorithms, we achieved 2 orders of magnitude improvement, 100 times. And when we completely rethought the Monte Carlo algorithms underpinning financial risk modeling, we achieved an almost incredible 10,000 times improvement. These are the kinds of results that transform industries, moving offline calculation, hindsight, to real-time insight. We achieved all of this on our HPE Superdome X systems. So you can start with memory-driven computing today. When we announced, we knew it had to be bigger than us. We knew we wanted to have that conversation, and we knew we wanted to collaborate. As an example, a leading medical research institute came to us to help them overcome intractable compute challenges in their search for a cure for Alzheimer's disease using memory-driven computing. And I'm thrilled to welcome to the stage Professor Pierluigi Nicotera and Professor Joachim Schulze from DZNE, the German Center for Neurodegenerative Disease Research. Thank you. Professors, can you tell me a bit about the DZNE mission?
Well, the DZNE is an organization funded by the German government to understand, to try to find strategies for prevention and care of neurodegenerative diseases, particularly Alzheimer's disease, which is, of course, a major problem for our society, particularly for Western society, but it's becoming a problem worldwide. And the idea is to bring together the very best brains in Germany and with colleagues around the world in collaboration to try to solve the problem. For the next few years, we expect very intensive research, which is based on a number of data coming from fundamental research, but also from clinical population studies, which means a huge amount of heterogeneous data that need to be understood and put together to solve a complex disease.
And what led you to memory-driven computing?
So we're talking about big data now in medicine. So we have genomic data, we have imaging data, we're looking at the brain, we have a lot of data where we follow patients for 30 years, maybe 30,000 patients where we want to learn about the disease. And so we need a lot of memory banks, basically. We need to access this data all the time. That's when we want to bring them together is absolutely necessary. So when we learned on the internet about the machine, which was open on YouTube, we said that's exactly what we need. We need basically an architecture where the data is in the middle, where we can put our medical data in and can access it all the time to calculate faster and integrative. That was how it happened.
And what have we achieved so far?
Well, actually, we started practically 2 weeks ago, and so we don't have too much time yet. And the first results are actually quite encouraging because we speed up calculations for genomic data up to 9 times. So with 2 weeks on our sort of roll, I think that this may hope for a huge, tremendous advance in the future.
So 2 weeks and you got 9x improvement. What's next?
So, we have only started to have a very tiny piece of our pipeline when we analyze genomic data, and the pipeline is much longer, and we have already 9 times faster. So we think, at least in the genomics field, we can go even 100 times faster when we really leash all what's possible. And then we go beyond that. We want to integrate genomic data. We want to integrate with imaging data, with the patient's history, with their drug data, and so on. And this basically goes beyond what we're doing right now. So we see a very, very bright future for this collaboration.
Well, thank you, professors. As someone who has experienced coping with these diseases in my own family, I thank you so much for your work, for our collaboration, and for helping me tell this story to our HPE Discover audience.
Thank you for having us.
Thank you.
So the question is, what path do you want to go down? Do you want to go down a conventional path that will lead to a dead end? Or do you want to go on a path that extends far into our shared future? Hewlett Packard Enterprise is the company that has your future taken care of. You're here today with the company that is defining the next waves of computing. You are seeing history being made, and you're a part of it. I invite you all, come to the Hewlett Packard Labs Pavilion, meet the technologists that have been given the opportunity to realize their dreams and their visions. Thank you.